In this section, we're going to study the standard form of a line, which you've seen before, but we'll look at again. Standard form of a line is ax plus by equals c, where a, b, and c are integers. So the example you see there, 2x minus 4y equals 7, is in standard form. Notice, can you see the slope out of that? At least not directly, right? Or the y-intercept, because it's not y alone. So pause the tape and write down standard form in your notebook. So if I gave you the equation in standard form and said find the slope of the y-intercept, you would do what we did in the last chapter. You would simply get y alone, negative 4y is equal to 7 minus 2x, divide by negative 4, so y is equal to negative 7/4 plus a half x, and then it's in slope-intercept form, so you can see that the slope is 1/2, and the y-intercept, which we recognize as b, is negative 7/4. In the last chapter, we looked at how some word problems lend themselves easily to slope-intercept form, where we had an initial value, which we called the y-intercept, and then a constant rate of change. Some word problems, though, lend themselves a lot better to standard form. So if you look at this example, you're in charge of buying the hamburgers and hot dogs for your club picnic. If the hamburger costs $5 per pound and the hot dogs cost $4 per pound, and you have $80 to spend, write an equation to model the different amounts of hamburger and hot dogs you can buy. So the two unknowns here are the amounts of hamburger and the amount of hot dogs. So if we call, just because they're both H's, I think this time I'm going to call X the pounds of hamburger, and Y the pounds of hot dogs, then the equation is pretty simply, you're going to take $5 per pound of hamburger, so 5 times X, plus $4 per pound of hot dogs, and again that's Y, so 4 times Y, and then that's, you've got $80 to spend. Maybe this time we'll just say equal to 80, but obviously you could spend less than that. So basically that would be your equation. Now it's in standard form, so if you wanted to graph it, think a moment of what was an easy way to graph that. So we used intercepts a lot when we had it in standard form. So if we determine the intercepts here, if we let x be 0 to find the y-intercept, we get 20. And if we let y be 0, right, 5 goes into 8 once, 30, 5 goes into 36 times, we get 16. So your first thing, if you wanted to graph that, would be to look at that graph and say, okay, how do I want to split up my blocks? So for x's, we have to go out to 16, so it looks like we could do 2, 4, 6, 8, 10, 12, 14, and we'll probably cheat and just do one extra block there. And then for the y's, we have to go up to 20, and I didn't give you much space there, so maybe we'll let the lines be 5. So these were 2, and these were 5. I wanted to see if it would fit. So 5, 10, 15, 20. So if you wanted to graph this, you could plot 16 on the x for the x-intercept, so 8, 10, 12, 14, 16. That's my extra little point up there. I'll make that 16. And then 20 for the y-intercept. And if we connected them, that line represents the possibilities. Now in actuality, which of those points really makes sense? Well, probably you'd want to have an integral value for both the number of pounds of hamburger. Maybe not. Maybe you could buy 1.5 pounds. But basically that line represents your possibilities. So it looks like if we bought, for example, 4 pounds of hamburger, I looked up, it looks like that's 15 pounds of hot dogs that we could buy for our $80. Again, check it. 5 times 4 is 20, plus 4 times 15 is 60, and that is equal to 80. So we can see that that point checks out. So again, the word problem lent itself to standard form because our two unknowns times a value for each of them kind of just fit into that ax plus by equals c. Once we had it in that form, intercept seemed like an easy way to go to graph it, and then the graph is just a visual representation of our different possibilities of what we could buy. So because of the different forms we use, sometimes we're going to want to change from one form to another. So in this problem, I'm giving you a problem in slope-intercept form, and we want to change it to standard form. So this is the first one, so I'll go through it with you. So y is equal to negative 2/3 x minus 5. So standard form says we can't have any fractions. So what we're going to do is multiply both sides of the equation by all the fractional denominators, or the common denominator, so in this case 3. So we're going to multiply the left side by 3 and the right side by 3, which will give us 3y equals, remember to distribute, so negative 2x, because the 3's are reduced there, and then negative 5 times 3 is negative 15. So that's not standard form because we just have by equal and the x's and the numbers are on the same side. So we want to move the 2x over by adding 2x to both sides. And that's considered now standard form. It's in the form of ax plus by equals c, where a, b, and c are integers. So take a moment to jot down that example, change it to standard form. So here's a second example. Change y equal 1/4 x minus a half to standard form. So this time, why don't you pause the video and write down that example in your notebook and try to change it to standard form. So when you're finished and you check it, I'm going to write the y equals 1/4 x minus a half. And I'm going to multiply both sides by the common denominator, which in this case is 4. So on the left, 4y equals, on the right, make sure you distribute, so 1/4 x times 4 is just 1x, and then minus a half times 4 is 2. Again, not quite standard form, so the second step is we want to move the x term over with the y. So we're going to subtract 1x. It is typical to put the x term first, that ax plus by. But it's also standard a lot of times to have the coefficient of x positive, to make the a positive. Now you don't have to. This certainly, what we just found here, fits the definition of standard form, where a, b, and c are integers. However, this is often written as a positive x, so now I'm distributing -1 on both sides, minus 4y equals positive 2. So basically, by multiplying by both sides by -1, I'm just changing all the signs. So very often you would see this, let's say in the answer book, instead of this one here, so you want to recognize that those two things are equivalent. So this problem says, given a line with point 3, -5, and a slope of 1/4, find its equation in point slope and standard form. So why don't you copy that down and then pause the video. So hopefully what you were thinking is, since you need point slope form, you're going to write down y minus y1 equals m times x minus x1. Plug in that point, so y minus a -5, and you can switch that right away to y plus 5, equals 1/4 times x minus 3. So that's the first answer. That's the first thing you want to find. That's point slope form. To change it to standard form, remember that involves a couple things. You need to get rid of any fractions. You need to get the x and y on the same side and the constant on the other side. So remember, standard form should look like ax plus by equals c, and it's just the a's, b's, and c's that are numbers. So in this case, if we want to get rid of the fractions first, we're going to multiply both sides by 4. Now that fraction, that's the coefficient of the parentheses. If we multiply 4 on the right hand side, As long as we multiply the coefficient of that whole parentheses, which would have been distributed, we're taking care of that all the way through. So this gives us, as we distribute here, 4y plus 20 equals, we're distributing 1 on the right, x minus 3. So there's the first part of standard form. The second part is to put everything on the right side so where they belong. So again, there's your pattern for standard form. So we need the x on the left. We're going to subtract x. We're going to keep the 4y exactly where it is, so don't change the sign. And then we're going to subtract 20 from both sides, which gives us a negative 23 on the right. And there's standard form. Again, frequently you'll see in books where the a, the coefficient of x, is positive. So a lot of times that would be rewritten as x minus 4y equals positive 23. So make sure when you're distributing that negative 1, you do both sides. The most common mistake is to leave that negative 23 there. Okay, this time we're trying to write the equation of a line given 2 points on it, 3, negative 2, and 6, 5, again in point-slope form and standard form. So why don't you copy that in your notebook and try to do that one first. So hopefully the first thing you did was find the slope. So no matter what form we're in, we're going to start with, well, point-slope or slope-intercept, we're going to start with the slope. So y minus y over x minus x. So negative 7 over negative 3, or a positive 7/3 slope. Now you'd have the choice, do you want to put it into slope-intercept form or do you want to put it into point-slope form? Since we're practicing point-slope form, I'm just going to do that one. So it'll be y plus 2, right, y minus negative 2, equals 7/3 times x minus 3. So that would be the answer in point-slope form. So that's the first one that we wanted to find. And then secondly, to change it to standard form, I need to get rid of the fractions. So I'm going to multiply both sides by 3. Again, make sure you distribute on the left when you multiply by 3. On the right, when you multiply by 3, you're just going to change that coefficient, and in effect that's multiplying by 3. So as we now distribute, we get 3y plus 6 equals 7x minus 21. Bring the x term over to the left, so hopefully that's what you did in your notebooks. So negative 7x plus 3y equals, and now subtract 6, so we get negative 27, and that's standard form. And again, if we want to write it in another way that's generally written more often, so maybe it's a little more standard, then we would rewrite it as, so try that. Okay, and did you say positive 7x minus 3y equals positive 27? So just go through and change all three signs, multiplying by negative 1 on both sides. Okay, now we're just going to look at horizontal and vertical lines. So we have a red vertical line there. So do you remember what's true about a vertical line? Hopefully you said it had no slope, and that's correct. And again, notice on that red vertical line, every single point on that line is left 3 blocks, right? So we know that has the equation of x equals negative 3. Now, that is standard form. It just so happens, in terms of ax, remember, plus by equals c. What's a? 1. What's b? So in this case, it's 0, right? Because there is no y term, and c is negative 3. So that is in standard form. So what would the equation of the blue line be? So think about which is the constant value, right? All those points are up 3, so the equation is y equals 3. Now that one actually happens to be both in standard form, where a is just 0, ax plus by, b is 1, and c is 3. And it's also in slope-intercept form. So it's just that m happens to be 0, which we know a horizontal line has a 0 slope. So that's equivalent to y is equal to 0x plus 3, and we wouldn't normally write the 0x in there, but that's where it comes from. So just a reminder, a horizontal line has a 0 slope, vertical line has no slope, which is why we can't put it into slope-intercept form, but we can put it into standard form, which is that x is equal to -3. Okay, so now when you read word problems, you've got 3 different forms you can use, and you just want to think about, well, what does it say? What makes sense to do? So let's look at this one. A mountain climber is scaling a 300-foot cliff, climbing at a constant rate. She starts at the bottom at 12 p.m. By 12:30 p.m., she has moved 62 feet up the cliff. Write an equation that gives the distance d in feet remaining in the climb in terms of the time hours. And what's the slope of the linear function? Okay, so if we want to write an equation that's that distance remaining, then we would want, to me this one seems like this would be good for our slope-intercept form. Like, what's the initial amount of distance she has to cover? So she's starting at the bottom and she has to go up 300 feet. So if we think in terms of her distance, well, the y-intercept, or the initial value she has to climb, is 300 feet. Now, taking away from that distance, right, so we can subtract that rate of climb for every hour, but we don't know the rate of climb, so let's figure it out. So that would represent the slope. So if we say slope is, in this case, it's going to be the change in distance, right, difference of y's, over the change in time. So in this case, we can see that she could go 62 feet in a half an hour. Right, so let's change that to a unit rate. So 62 feet, we're going to multiply by 2 over 1, right, and that hour is going to stay in the denominator though. So we're going to get 124 feet per hour. Right, so our equation would be d is equal to 300 feet minus 124 feet per hour. All right, and that would be times t, how many hours you're going to plug in. So why don't you stop and look back over that. So we had the 300-foot cliff, so that's all the distance she has to cover. Figured out her pace, 62 feet per half hour, which is 124 feet per hour. That became our slope. And again, why is it a minus? Because that rate of climbing every hour is taking away from that distance that she has to climb. So that becomes our formula. So now secondly, when will she reach the top? Well, in this case, if we use that formula we just found, d is equal to 300 minus 124t, when will she reach the top? Well, what's the distance at the top? Again, she's trying to scale the 300-foot cliff, so at the top, there's no distance remaining. So we're going to put a 0 in for the distance. The rest of the formula stays just as it is, and we're going to solve for time. So we subtract 300. And then divide by negative 124. So negative 300 over negative 124. Okay, and you can crunch that. You can reduce it, crunch it on your calculator, but you're going to get 2.4. I wrote about hours. Actually, it looked like it might reduce really well, but it doesn't. It just goes down to 75 over 31. So anyway, that is approximately 2.4 hours, and that's when she'll reach the top. Okay? So you'll do some work tomorrow in class on the 3 forms, but again, to review, we had the y equal mx plus b, which is the slope-intercept form. So you want to make sure you have a working knowledge of all 3 of these. So slope-intercept, and then our second one was the point slope, and again, that sounds just like the way it looks, or it writes just the way it looks, you're going to have a point and a slope in there. So y minus y1 equals m times x minus x1, where x1, y1 is a particular point. And then we have our standard form, which is ax plus by equals c. So those are your three forms of lines which come up a lot. Again, on that last one, a, b, and c are integers. So in terms of word problems, you're going to take a look at, see which one makes sense. In terms of finding the equation of the line, again, usually you're going to work with either the slope-intercept or the point-slope form, because that's usually where you can plug in the slope. And if you need it in standard form, you'll change it after you find those two. So go back and replay anything that you need, or study your examples that you wrote in your notebook, and be ready to work on these tomorrow in class.